Welcome to day three of the Applied Digitalization for Oil and Gas course. Today we are going to focus on the topic of integrated cybersecurity for digital infrastructures. First, we gonna address the threats and its implications on the future of digital oil field, and after that we gonna discuss the oil field as a critical infrastructure, and then gonna compare cybersecurity to physical security to take a closer look at the major differences and how the future security is going to evolve and dynamically emerge. And then we're going to address the solutions and the policies and regulations about it, and the cybersecurity for the supply chain of vendors and sub-vendors. This is a survey that was done by Semantic, which found that around 30% of organizations regularly face cyber attacks, and around 70% of these organizations have been attacked in the past 12 months only. The nature of the attack was more of malicious in nature and social engineering purposes. This resulted in losses in production, as well as loss of private data and company data, as well as industrial incidents, because cybersecurity is all about managing cyber initiated physical incidents. If we look at the bottom line of the cybersecurity challenge, the use of digitalization means that now we have globalization of our operations and business, which results in hyper connectivity of the entire supply chain, such as the connection of the office to the field, and from the field to the pipelines and midstream, all the way to the retail. This results in digital over reliance or dependency that can lead to complacency if we are not taking into account cybersecurity, and the commercialization of the technology markets, where technologies are not defense based but rather more of user friendly, could result in cybersecurity breaches. And the differential growth rate, the exponential rate of change in technology is ways faster than most organizations can adopt, which results in a blurring line between the physical world and the digital information world, the physical analog world and the digital information world, which results in overlap. And ultimately, this overlap can create some boundary problems and cybersecurity exposures. Again, the oil and gas field is a critical infrastructure. We can see the integration, how we can monitor and connect these multiple components of the system. The assets that are used in the oil and gas industry are very long lived. We're talking about decades, 50 plus years, such as plants. The extended infrastructure, the remote location nature of such structures, the long extended pipelines, as well as the geopolitical exposure, as oil and gas operations are connected to the government, its economy, as well as its function. This is a simplified control model where we see the equipment and the control model, the distributed control system, and the programmable logic models. And here we have the cybersecurity layers, and then we get the corporate local area network. The information security is essential because any loss in the data or data gap can result in industrial incidents and issues that can impact the performance of the company. Thus, it's essential to ensure and assure the information and data flow in the system to enable high levels of operational excellence through adoption of practical cybersecurity solutions. This is an example that shows the hyperconnectivity and the extended nature of the oil and gas assets and the value of information in and out from the control room, for example, to the separation or to the drilling site or the production and the producing facilities. The information here is very valuable. It means time, it means money, as well as the real-time nature of it can enable real-time analysis and decision making that can result in more of proactive operations mode as opposed to reactive. This table shows a comparison between the traditional physical security, which is physically bounded, whereas the cybersecurity is boundless. Anything that is connected to the system and the network is going to be impacted. In terms of speed, physical security is the speed of a truck, whereas cybersecurity incidents are at the speed of light. As far as detection hints, for physical security, there are physical hints, whereas for cybersecurity, there are online hints, such as anomalies in data and disruption in the monitoring. The experience that we have is very well established for physical security. The cybersecurity threat itself is evolving and emerging. Those who are still in terms of control and solutions, it is more of a journey rather than a destination that requires a combination of both cyber and physical security integration. This shows the pillars of integrated security, which takes into account information technology security, operational technology security, as well as the traditional physical security, bringing them together, linked and connected side by side. If we talk about physical security, the responsibility is to have physical control over the access to the plant or the building, and it is deployed at facilities, buildings, network centers and information centers, any critical operating assets such as drilling sites and well completion sites, as well as the transportation corridors and centers. The security mechanism used is authentication, using something that you have, such as your identification card or badge, or something that you know, like personal identification number, or something you are, such as voice recognition and biometric. Operational technology, the main responsibility is to monitor and protect critical operating infrastructure systems, such as industrial control system, distributed control system, supervisory control, and data acquisition. The main components of the operational technology security and relevant components is the supervisory systems, the sensor networks out in the facilities and equipment, the remote terminal units, which sometimes host the programmable logic controllers on them that has the logic. The mechanism of the security is monitoring the state, the chemical or the physical state of the processes, the devices, and the systems. Any disruption or change will indicate operational technology exposures and vulnerabilities. Last but not least is the information technology security. The responsibility here is to protect your privacy, the data, and its integrity, to validate the data, as well as the availability, as mentioned earlier, the information value and the network resources associated. It's deployed across the corporate, including both remote nodes in the field as well as mobile nodes such as iPads and mobile phones. The security mechanism, it is authentication and beyond. The security components include security incident and event management, the the identity and the access management, such as the access to corporate devices. It does also scanning for vulnerability, patch, and configuration management. However, it's still new and emerging with multiple firewalls, redundant antivirus software, and defenses. This shows the application of the risk management matrix for cybersecurity. It looks at the causes, the consequences, the preventive measures, as well as the reactive measures. The following table also summarizes the risk management exercise, which is a very useful exercise to help assign responsibilities for the multiple components and human resources involved with it. And the key here is that it's, as highlighted earlier, it's a dynamic journey, not a destination, because the challenges are evolving. And these risk management exercises needs to be done frequently and periodically to account for the change of management and the emerging threats. This is an exercise where you can apply the risk management that we have learned in the previous slides to a threat in your organization, a cyber threat. You need to identify what is that risk. Is it an attack from your contractors, your subcontractors? Is it a loss of the data? Is it an internal threat to one of your employees? And you need to assign the responsibilities, who's responsible for what, and evaluate and verify, as highlighted earlier, periodically to account for the change management and the arising threats. Also, the generation and the psychological aspects has direct impact on cybersecurity. The nature of information technology is entirely different from operational technology. A lot of the younger generations tend to bring their attitude around information technology to the workplace where we have operational technology. The key here is to realize that the challenges and the seams are bounded to materialize and at very fast rate. Those you need to account for it as part of your policies and management. And also view these digital technologies as digital assistants, but not as something that's gonna replace the human factor at the workplace. And the young generation is not interested to move to work to remote work locations because they always wanna remain connected and have a connection to high-speed internet and enjoy the leverage of mobility and connectivity. And it's very evident that the digital strategy needs to own the digital transformation program and account for the human capital as well as the digital capital, which is basically the information that you retain through the digital technologies, which represents a great asset. This is a case study for an incident which is took place, which is a drone attack on Saudi Aramco pipelines in two major fields at the same time. So they want to cause a major disruption to different locations, Abqaiq and Khores. This case is available online, and it's highly recommended to take a look of it, and you see the use of drones to create offensive attacks on oil and gas facilities. And this is another case of cyber attack on oil and gas facility, which is also available online. It's highly recommended to look at this cyber attack and study the lessons learned from it. The industrial safety system. There are two types of the safety instrumented systems. There is emergency shutdown and emergency depressurization. Each one is suitable for a specific action. The automatic safety is for the purpose of prevention, so that it can suspend prior to an incident. And it's very important to have the correct operation sensing device, the connection to ensure harmony, and follow the entire life cycle from installation all the way down to commissioning. It's very important to account for the vocabulary used, because different standards use different vocabularies, and this should be accounted for, because the global structure on cybersecurity is still evolving, and it has a big growing gap. This is a basic network architecture for deployment. It shows the control room, the engineering office that makes the decisions, and the servers and the operator that has the dashboards and the monitoring screens, and then the field. And we can see here the deployment of firewalls in between. And these are multiple deployment. Each one is case specific, and it is a compromise between efficiency and cybersecurity. The lessons learned from digitalization and cybersecurity in the oil and gas business is that these models are very complex. As we have seen, they are multi-organizational, multi-dimensional, and it involves human and psychological aspects, government and regulation, financial and economics, as well as technology and science. Those we have to account early for the cybersecurity breaches, and become aware of the fact that these digital twins and logical representation can never be exact duplication. For instance, the behavior of your contractors or your internal employees cannot be accurately represented in the logical cyberspace. And as we discussed earlier, the architecture needs to hit a compromise between operational efficiency and security, and the decisions get to account for change management and flexibility. The cybersecurity solutions set a general framework, and this needs to be tailored for each specific case. And the implementation of culture change is important, and it has to relate to how things relate to each other. Also, you need to identify the operational control points and the risk point for each specific function. For example, for the storage, for the pipeline, for the drilling, for the completion. And needless to emphasize the threats are emerging, and we need to look at the generational aspects and the psychological aspects on cybersecurity. This is a paper that we published in Saudi Aramco Journal of Technology. It highlights the impact of generational gap on cyber security, and it discusses some of the important cybersecurity policies, compliance, and regulations. This is an exercise where you create a cyber security strategy for your contractors and subcontractors, and develop an open community uh, information page for health, safety, and environment issues related to the fourth industrial revolution. Need just to set the background, what is the current scene, what is the existing case, and the approach, how you're gonna leverage the cybersecurity skills, the health of the employees in the digital age, their safety and their wellness, as well as environmental protection, as we have more traceability nowadays and feasibility thanks to emerging digital technologies, and what are your findings and recommendations? This concludes day three. Thanks.